The city of Chicago just launched DIvvy, a citywide bike rental system which allows people to borrow and return bikes at any station across the town very conveniently. However, like many other bike sharing systems in the United States, DIvvy faces a big problem. While some stations do not have enough bikes for riders to check out, other stations are lack of empty docks for riders to park their bikes. To prevent this problem, DIvvy bike share operators need to drive trucks across the town to reallocate bikes from full stations to empty ones. However, the operators can only see the current number of bikes at each station, but have problems with estimating the number of bikes at stations in an hour or two. So without knowing how many bikes at each station in the future, the operators are not able to reallocate bikes proactively across the city. Therefore, our team Reclassify Pro designed a cell phone app named DIvvyX. The app will be based on a predictive model forecasting future number of bikes at each DIvvy station across Chicago. By using our DIvvyX app, bike share operators can easily check how many bikes are likely to be at each DIvvy station in the future. Therefore, our app can help them reallocate bikes more proactively and plan their work every day more efficiently. As bike share operators log into their accounts, they can enter the station name and time period that they want to check for bike count prediction. We create an auto-suggested design in our app. As users just type a keyword in the search box, all related station names will pop out, and the users can simply select what they want. Meanwhile, the drop-down menu for the time selection also enhances the user experience. Based on the user inputs, our app will show how many bike trips will take place at the input station as well as the stations nearby during the selected time period. According to the future bike trip prediction, our app provides a color indicator for probability of empty docks at stations, where red text indicates high probability of empty docks and green indicates low. In addition, more detailed information about the selected station will be shown at the bottom of the interface. Moreover, operators can click the suggested route button to see the best route to drive around and rebalance bikes. This feature will show them how many bikes they need to pick up or drop off at each station. In addition, our app also provides some summary graphs showing bike trip change for the selected station over time, as well as some useful information of the selected station at its nearby station, such as whether the station needs to be refueled. How does this app work? Well, we built a Poisson regression model based on 1 week hourly bike trip data at 150 DIvvy stations in downtown Chicago. The model uses a lot of spatial and time variables as predictors to forecast the number of bike trips departed from each DIvvy station. We'll also use the model to predict the number of bike departures on one following weekday and weekend day, which could help test the predictive power of our model. Our model results show that most of our predictors are significant. Among all predictors, spatial variables have the greatest influence on hourly departure bike trips. Since it is a great challenge to rebalance bikes during rush hours, we also create the percent error maps to visualize how well our model predicts spatially for rush hours over a week. These maps show that our model predicts better for stations near the central business district in Chicago. Our model performs well for predicting future bike trips. The chart shows that many of our predicted hourly bike trips match with the actual values. Also, these 7 maps show that our model captures a general trend of bike trip change during each day of a week. Especially for weekdays, our predicted results match very closely with the actual bike trip counts. The model results indicate that there are some possible ways to enhance the model, such as adding more predictive variables. Also, in addition to the hourly departure bike trips, we may use the hourly change of bike trips at each station as our dependent variable. Lastly, we may consider using a nonlinear regression model to capture the distinct trends of each individual station. These potential improvements would better support the function of our app and benefit DIvvy Bikeshare system in the future. Thank you for watching.